Whenever any important topic is there, I will go on explain on board some topics only. But already what you know, well-known questions, explanation is going on right now. Okay, start just now. Right, all of you just listen carefully. Right. Okay, students, this is the final revision for the physics exam, for the board exam. All of you listen carefully. I am going to explain the very important questions which may expect in the coming board exam. From each and every lesson I will tell you minimum 3 to 5 important questions. If you prepare well, definitely you can score the more than 90%, means out of 40 marks it is easy to get the above 36 marks. If you get the 36 marks, that is A1. So to get the 36 marks, if you prepare these question answers in every lesson, then definitely it is easy to get the above 36 marks in your physics exam. So listen, first lesson especially you have to concentrate 3 important questions. Number 1, ray diagrams of concave mirror. Okay. Number 2, differences between the real image and virtual image. Number 3, what is magnification? Based on magnification value, questions can be framed. So for example, what I said in the first question, ray diagrams of concave mirror means they may not ask directly draw the ray diagram of concave mirror when object placed at center of curvature, or when object placed between P and F, or between C and F. But indirectly, recently you have seen in pre-final exam, some data based question will be given, means object position, image position will be given, but you have to answer the based on the data. They will ask the question, means for example, already if center of curvature object is placed, image also formed at center of curvature. So question how they frame, what, where the, in which of the following case magnification is -1. -1 means in concave mirror it is -1 when object is placed at center of curvature. So where the object, if object is placed at infinity, where the image can be formed? At focus. So there are 6 familiar positions of object, you know. When object is placed at infinity, image is formed at focus. When object placed beyond center of curvature, image is formed between F and C. When object placed at center of curvature, image formed at center of curvature. When object placed between F and C, beyond center of curvature. At F, at infinity. Between P and F, inside the mirror, virtual image is formed. So last one case only different, that is virtual, erect, enlarged image is formed. Remaining 1 to 5 cases, real and inverted images are formed. So finally, this ray diagrams of concave mirror is very important question in this lesson. Next, daily life applications of concave convex mirrors in this lesson. Daily life applications are very important. Based on the applications, one important question is there. Which mirror is used as rear view mirror for vehicles? Indirectly, that is convex mirror is answer, or indirectly they may ask the question, what happen if concave mirror is used as the rear view mirror for vehicles? So if you use the concave mirror as rear view mirror, image is formed real inverted images. So the image of the vehicles cannot be judged clearly. That is why we should not use the concave mirror, we should use the convex mirror only. So in this lesson, if you prepare these 4 questions, the lesson will be completed. Number 1, ray diagrams of concave mirror. Number 2, what are the differences between the real image and virtual image? Number 3, what is magnification and application based questions? Application based means if magnification is +1, what does it mean? That is one of the application based question based on the magnification. Number 4, daily life applications of concave convex mirrors. Okay na? This is the final revision for the first lesson. Next, chemical equations is there. In chemical equation, only 2 important concepts are there and 3 questions are there. Number 1, how to balance the chemical equation. Okay, balancing chemical equations is very important. Some familiar balancing chemical equations I will write. So those if you practice well, then definitely can be expected some of the questions. Balancing chemical equations, for example, C3H8 plus O2 gives rise to CO2 plus H2O. So this is one of the important balancing chemical equation. Recently this question is asked for 6 marks, 5 marks question in the previous exam. So not only that, some simple equations also are there. H2 plus O2 gives rise to H2O. These are unbalanced equations what I am giving. KClO3 gives rise to KCl plus O2. Okay. Next, some other chemical reactions are there. N2 plus H2 gives rise to NH3. So balance the following equation. So whenever you are balancing the equations, it is very important. You have to take the appropriate number as coefficient of the molecule. So you know already directly I can write here the balancing equations. You know the stepwise method also. We have to take the what are the number of elements present in the equation. What are the elements? LHS, RHS. Number of elements we have to count. In order to balance that appropriate number, we have to take the balancing equation. So first you know already C3H8 plus 5O2 gives rise to 3CO2 plus 4H2O. This is the balanced equation for first one. Next, second one is 2H2 plus O2 gives rise to 2H2O. This is the second one. And third one, 2KClO3 gives rise to 2KCl plus 3O2. And fourth one, N2 plus 3H2 gives rise to 2NH3. So these are the some of the important examples which can be expected how to balancing the chemical equations. In this lesson, related to this question, why we should balance the chemical equation, 2 marks question. According to law of conservation of mass, the number of reactants must be equal to number of products, or total mass of substances in reactants and product side equal. So that is about the why we should balance chemical equation, balance the following equations. And in this lesson, one more question is there, what information will be given by the balanced equation. And related to chemical reaction, exothermic endothermic reactions are very important. They may ask, write the differences between exothermic endothermic reaction, or explain with an example for each exothermic and endothermic reaction. The chemical reaction in which heat energy liberated is known as a exothermic reaction. The chemical reaction in which heat energy absorbed is known as endothermic reaction. So examples also you have to remember that. So whenever energy is liberated, it is indicated with a plus Q symbol. Energy is absorbed with minus Q symbol. So in this lesson, remember these are the important questions. Number 1, balance the following chemical equations. Number 2, why should we balance a chemical equation? Number 3, what information given by the balanced equation? Number 4, explain the endothermic and exothermic reaction with suitable examples. So these are the 4 questions from the second lesson. So now we will go to the third lesson. Acids, bases and salts, 3 important concepts are there, and 5 important questions I will tell you from that. Number 1, related to the indicators, how the acids and bases we can find by indicators. Methyl orange, phenolphthalein and litmus paper, these are the very important. General concept we know, acids will turn the blue litmus to red, bases will turn the red litmus to blue. But methyl orange and phenolphthalein indicators also very important. Methyl orange in presence of acids, red color, in presence of bases, yellow color, and phenolphthalein acids colorless and bases pink color. So these are the important indicators. Next, chemical properties of acids, bases, very important. There 2 activities are there. Okay, so 3 activities previously asked in the board exam also. Number 1, what happens when acids and bases react with metals? For example, that is lab activity. Zinc when react with hydrochloric acid, it produces zinc chloride and hydrogen gas. Zinc chloride and hydrogen gas. So this is the lab activity based important question. You have to prepare for 6 marks question. And second one is, what happens when metal carbonates, metal hydrogen carbonates react with acids? Metal carbonates means Na2CO3, sodium carbonate, and it react with hydrochloric acid. It produces sodium chloride, salt, plus water plus carbon dioxide. So important here, when metals react with acids, it's releasing the hydrogen gas. When metal carbonate react with acids, it's releasing the carbon dioxide gas. Generally they may ask in the 2 marks also, how can you test the hydrogen gas, or how can you test the carbon dioxide gas? So whenever a gas liberated it is put off the flame with a pop sound, it is indicating the hydrogen gas. Whenever you pass the carbon dioxide gas through the lime water, it will turn to the milky white. So that is the testing of carbon dioxide gas. So next, metal hydrogen carbonates also same, NaHCO3, metal hydrogen carbonate, sodium hydrogen carbonate plus HCl acid, it is also producing the same salt, water and carbon dioxide gas. So these two are 4 marks expected questions, activity based. And next, neutralization reaction is there. A chemical reaction takes place between acid and base to give the salt and water, is called as neutralization. An acid is HCl, hydrochloric acid, a base is sodium hydroxide, NaOH, and it is producing the sodium chloride, NaCl, and H2O water. So here this chemical reaction also very important, this is called as a neutralization reaction. A chemical reaction in which an acid react with base to produce the salt and water is called as neutralization reaction. Along with these 3 activities and questions, how do acids will conduct electricity? By taking the hydrochloric acid, sulfuric acid and glucose alcohol, we can prove that only acids will produce the electric current, because they dissociate into their ions, H plus ions and Cl minus ions, hydrochloric acid, and H plus ions produced by the sulfuric acid also. So this is also one of the activity based question. And finally in this lesson, pH importance is important. Okay, daily life, tooth decay, digestive system, pH of the soil, these 3, one can be expected importance of pH. And then after this, removing of water of crystallization method, removing of activity based question is there, removing of water of crystallization, that is also one of the important concept in this lesson. Finally, what are the 5 questions are? Number 1, testing of acids bases with indicators, 1 mark bit part, 2 mark short answers. Number 2, activity based questions, what happens when metals react with acids, or explain the evolution of hydrogen gas when metal react with acid. Next, how do acids will conduct electricity, explain the pH and its importance. And based on pH scale also they can frame the question. In a tabular form they will give the pH values, A, B, C, D are the some substances, pH values are 2, 5, 7, 10, 14 will be given there. Based on that some application questions can be framed. What are they? What is the new product can be produced? A react with D. It may be A is a strong acid and D is a strong base. It is a neutralization reaction you have to write. So you have to understand that there are 3 types of salts: acidic salts, basic salts and neutral salts. Strong acids react with weak base to produce the acidic salts. Strong base react with the weak acid to produce the basic salts. Strong acid, strong base to produce the neutral salts. So you have to remember that pH scale is introduced by Sorensen scientist. It measures the values from 0 to 14. Less than 7 are acids, greater than 7 are base, and 7 value is the neutral. So in pH scale, some of the substances also given. What are the strong acid and strong bases and neutral substances? So distilled water is the neutral. Example for the pH value 7. Hydrochloric acid and sulfuric acid, strong acids. Sodium hydroxide is a strong base. So these are the some concepts in the 3rd lesson. 4th lesson is very important, ray diagrams of convex lens. Bird and fish activity, that is one of the example question is there. How the bird appear to the fish or how the fish appear to the bird. So reversely they may frame the questions. In our textbook given that example is how the bird appear to the fish. So that concept is the bird appear far away from its original place and faster than its original speed it will appear, because of light rays travel from denser medium to rarer medium, from water to air. The refracted ray move away from the normal and appear from the original distance. So in this lesson, lens formula, lens maker's formula also important. Lens maker formula 2 marks question can be expected. Problem based questions you have to practice. Whenever you are solving the problem, you have to keep it in mind. Sign convention rules are very important. So sign convention rules in 1st lesson, 4th lesson same apply. Okay, applicable. Those are all the distances should be measured from the pole. The distance is measured in the direction of incident ray positive, in opposite to the direction of incident ray negative, and heights of the objects and images Above the principal axis positive, below the principal axis negative. So these three are the sign convention rules. Okay, right. We will go to the fifth lesson. Eye defects are very important. So myopia, hypermetropia, presbyopia. Questions can be framed in indirect way also. Defects will be given and questions will be framed like this. Doctor advised 2D lens. What is the focal length of that person? Or a person is unable to see the nearer distance and can see the far distance, and what is its defect? Okay, so or the person can see very near clearly, cannot see far. So remember the concept very clearly. If a person can see near, cannot see far, that is myopia defect. If a person can see far, cannot see nearer, that is hypermetropia defect. And due to the age factor, due to the weakening of ciliary muscles, that is called as presbyopia. So in this structure of human eye, what is accommodation? That is a short answer. What are the function of the retina? Okay, that's also. So especially eye defects and correction methods along with the diagrams you practice in the fifth lesson. And sixth lesson, in the structure of atom, very important concept is Bohr's model of hydrogen spectrum. All of you practice well. Bohr's model of hydrogen spectrum, 4 quantum numbers and 3 principles are there. Bohr principle, Pauli's exclusion principle and Hund's rule. So these are the very important principles. Once remember these 3 rules I will explain. Bohr principle is this is related to filling of electronic configuration. Our electronic configuration can be built by placing the number of electrons from lowest energy level to highest energy level until completing the total number of electrons, which is equal to atomic number. So that is the electronic configuration build up by lowest energy level to highest energy level. So s orbital should be filled, next p orbital, next d orbital, next f orbital. So this is the sequence of filling of electronic configuration. Next in this lesson, so finally 3 concepts are there. Remember, Bohr's model of hydrogen spectrum related to quantum numbers and 3 principles are there. Okay na? So Hund's rule is pairing of electrons takes place after filling of 1 electron in each orbital, and no 2 electrons will have 4 quantum numbers. That is the Pauli's exclusion principle. And we will go to the 7th lesson. Yes, in the 6th lesson, diagram based questions are there. Electromagnetic wave, okay, and also SPD orbitals. 6th lesson is a diagram oriented lesson. Electromagnetic wave, SPD orbitals are very important. Practice well. And in the 7th lesson, only 2 important topics are there. Main 4 classifications, periodic properties. 4 classifications, 2 very important. Dobryna's law of triad, Newland's law of octaves, Mendeleev periodic table, modern periodic table. Out of these 4 also, everyone must practice short answer type Dobryna's law of triad, essay type modern periodic table. Either Mendeleev or modern periodic table. Out of these 2 also, many times modern periodic table is asked in the previous exams. Concentrate well, Mendeleev periodic table and modern periodic table also essay type questions. And then there are 8 periodic properties, but 3 properties very important. Atomic radius, ionization energy, electron affinity. How they are changing in the period and group is very important. So first, atomic radius in a period from left to right decreases, in group from top to bottom increases. So next, related to ionization energy, factors affecting ionization energy also very important. There are 5 factors. Number 1 is nuclear charge. Number 2, screening effect. Number 3, penetration power. Number 4, atomic radius. Next, number 5, stable configuration. So these are the very important factors related to the factors affecting ionization energy. So in this lesson, these are the very important. We will go to the 8th lesson. Very important concepts are 4 theories are there. 1 will come surely. Valence electronic theory, valency bond theory, Westphal theory. Westphal theory means valency shell pair electron, valency shell electron pair repulsion theory. Okay, valency shell electron pair repulsion theory is called as Westphal theory. Valency bond theory is very important. and hybridization concept in this lesson. Hybridization. I'll tell you some molecules to prepare in this valency bond theory. Formation of N2 and O2 molecules. In hybridization concept, beryllium chloride and boron trifluoride, BF3. Okay, boron trifluoride. These are the molecules I have to prepare in these theories. Okay, in Westport theory, molecules are there: methane molecule, NH3 ammonia molecule, and H2O, and also CO2. These are the molecules are there. Westport theory is explaining about the bond angles. Recently in bit part they asked one question: methane bond angle 109 degrees 28 minutes. Okay, and what is the bond angle in the NH3 ammonia? 107 degrees 41 minutes. H2O 104 degrees. CO2 180 degrees, linear structure. So if you remember the bond angle and the shape of the molecules can be expected in the bit part as 1 mark. So they are, and finally, what are the properties of ionic and covalent compounds? Okay, that tabular form of question you have to prepare in this lesson. So next we'll go to the 9th lesson. Electric current, very important is the Ohm's law is the important concept. And in this lesson, according to, along with the Ohm's law, you have to practice about the series and parallel connections, and Kirchhoff's laws are there. Loop law and junction law are very important. Junction law is nothing but this is a 1 mark and short answer question can be expected. So I1, I2, I3, I4, I5 and I6, suppose it is given. Some of the values will be given there and one of the current will not be given. You have to find that the sum of the currents enter into the junction must be equal to sum of the currents leaving from junction. This is called as junction law. So this is called as junction law. According to the what is the direction of current given, you have to find the sum of the currents what is given, what we have to find. Okay. So in the 9th lesson, the factors affecting resistance also very important. There are 4 factors. Every time asked 2 factors. First, number 1 is nature of the material, temperature, length of the conductor, area of cross section. 4 factors are there. Length of the conductor, area of cross section of conductor, very important. Factors affecting resistance, these are the very important. In this lesson, you have to concentrate the short answer type. What is the current? I is equal to Q by T formula. Okay, Q by T formula. Differences between potential difference, EMF. Okay, na? Next, Ohm's law. What are the factors affecting resistance? Parallel series connections, resultant resistance. Resultant resistance means if 3 resistors are connected in series, what is the equivalent resistance? R is equal to R1 plus R2 plus R3. In the derivation part you have to practice. If 3 resistors are connected in the parallel, what is the resultant resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So this is the related to series and parallel connection resistances. So finally in this lesson you have to prepare. Number 1, Ohm's law is very important, lab activity based question. Differences between potential difference and EMF, factors affecting resistance. Okay. Next, some application type questions also are there. Those are the what is the use of the fuse in loading, overload of the electric appliances. To protect the electrical appliances, importance of the fuse is there, last topic. So these are the some important questions in the 9th lesson. Next, 10th lesson, electromagnetism, especially very important is electromagnetic induction. Faraday's laws are very important. Faraday's laws and their applications. And Oersted experiment is very important. Okay, Oersted experiment, Faraday's law of electromagnetic induction, electric motor working and principle, AC DC generators, diagram based questions. Generators, electric motor, diagram based questions in this lesson. So especially number 1, Oersted experiment, relation between the current and magnetism. Indirectly questions can be framed, you have to practice like that. Explain the how Oersted is given a relation between the current and magnetism. That is the relation between the electric current and magnetism. So that is the Oersted experiment. Next one is electromagnetic induction concept important. Magnetic field due to solenoid is important. 3 are there: straight wire, loop, circular loop, and also solenoid. magnetic field due to solenoid is important in this 3. When magnetic field due to solenoid is, that solenoid will act as a bar magnet. Okay, north and south poles of bar magnet, how it is acting as, then a solenoid also will be acting in the same. Okay, so now finally we are coming to the end point, that is the 11th lesson is very important in the diagram based question also. Extraction of metals, 3 types are there, you know already. That means concentration, extraction of crude metal, refining or purification. So in concentration or dressing, froth flotation is very important. You know, hand picking, washing, froth flotation, magnetic separation. So froth flotation, magnetic separation, the 2 important, along with their diagrams you have to practice. And in this lesson, extraction of metals in the highly reactive metals. There are 3 different types are there. Moderate reactive metals based on the roasting and calcination. 2 marks question can be expected. Write the differences between roasting and calcination. Heating the ore in presence of oxygen at high temperature is called as roasting. Heating the ore and absence of air is calcination. Okay, roasting is for the sulfide ores and calcination for the carbonate ores. Okay, zinc carbonate, calcium carbonate, that is an calcination. Zinc oxide, lead sulfides can be converted into the oxides, that is a roasting method. Okay, in this lesson again the very important corrosion activity is very important. Corrosion, how do you prove that? Moist air and water very essential for the corrosion. And daily life applications, how can you prevent the corrosion? Prevention methods are there. Recently they asked a question, that is painting, oiling, and also galvanization method, electroplating method, alloying method. These are the some of the general prevention of the corrosion methods. And finally reverberatory furnace, blast furnace. Some important terms are there. What is flux? Smelting. Smelting is a pyrochemical process where the ore can be heated. Flux is the substance which is added to the ore to remove the unwanted waste materials. So these are the from 11th lesson important questions. And 12th lesson 3 important concepts are there. I will tell you 5 questions. Number 1, hybridization concept. 3 hybridations are there. sp3, sp2, sp hybridization. Molecules also remember, then you can easily write those concepts. sp3 hybridization, methane molecule, formation of sp3 methane molecule, CH4. Okay, sp2 hybridization, C2H2. Okay, C2H4. sp hybridization, C2H2. Okay, this is methane. This is methane. Okay, this is ethene. This is ethine. So it is a double bond. This is single bond compound, carbon carbon. This is double bond compound. This is triple bond compound. Next, types of carbon compounds are there: saturated, unsaturated. So alkanes are called as saturated carbon compounds. Alkenes, alkynes are called as unsaturated carbon compounds. Single bond compounds are called as alkanes. Double bond and triple bond compounds are called as all unsaturated hydrocarbons. Next in this lesson, allotropic forms of carbon is there now. Diamond and graphite are very important. Crystalline forms of carbon is very important. Diamond, graphite, C60, Buckminster Fullerene. So these are very important. And one mark bit part I will tell you, that is the catenation. The ability of carbon combine to form the longest chains, or this is called as self-linking property of carbon is called as catenation. Okay. Next, in this lesson there are 4 chemical properties of carbon compounds. Number 1, oxidation, combustion, addition, substitution reaction. Okay, so these 4 are the very important. Previously 2 chemical properties asked for 4 marks question, that is oxidation reaction, addition reaction and substitution reaction. Especially addition reactions are very important. Addition reaction is nothing but the process of conversion of the unsaturated carbon compounds into saturated carbon compounds is called as addition reaction by adding the hydrogen in presence of nickel catalyst. Okay, for example, butane is converted into butane. Butane in your addition reaction example, butane will be converted butane will be converted butane. So this is the one of the addition reaction by adding of hydrogen in presence of nickel catalyst. Okay, in presence of nickel catalyst by adding of hydrogen. Where we use this type of reaction means in the hydrogenation of oils. Okay, unsaturated carbon compounds of the oils can be changed into the fats. Ghee like fats can be converted. So this is about the addition reaction. Substitution reaction, recently in your prefrontal exam also you have written, that is paraffins or saturated hydrocarbons are participate in the substitution reactions. Chlorine. Substitution reaction means all of you remember, some members written only one example. If you write only one example, you will not get the 4 marks. Substitution reactions are series of reactions, 4 are there. 4 you have to write. So CH4 methane Cl2. So CH3Cl plus HCl. There is a sequence you can remember easily. Then CH3Cl plus Cl2 gives rise to CH2Cl. One hydrogen is replacing always. So again HCl. Next CH2Cl plus Cl2 gives rise to CHCl2. CHCl2 here CHCl3 and HCl. Next CHCl3 plus Cl2 gives rise to CCl4 plus HCl. Okay now. Methyl chloride, methylene chloride, chloroform, carbon tetrachloride. Every time one hydrogen is replacing with chlorine. So that's why see here 4 hydrogens, 3 hydrogens, 2 hydrogens, 1 hydrogen. And again chlorines are adding. So here CH2Cl2, 3, 2, 1. Like that chlorines are adding here. CH3Cl, no? CH3Cl. Next CH2Cl2. Next CHCl3. So CCl4, carbon tetrachloride. A series of 4 reactions if you write, then only you will get the 4 marks, full marks, whatever the question is asked. And in this, the finally ethanol and ethanoic acid chemical properties are there. Ethanol is alcohol, C2H5OH is the formula. Especially when it reacts with sodium, it produces hydrogen gas. There is one important activity, glacial acetic acid react with ethanol. Acetic acid react with ethanol, it produces the esters. Esters are the sweet smelling substances which can be produced by the reaction of ethanol and ethanoic acid. Ethanol is ethyl alcohol only, C2H5OH. Okay, acetic acid is generally CH3COH acetic acid formula. When both react each other, that is an activity is given. We have to take a test tube, 2 ml of ethanol, 2 ml of acetic acid. We have to heat in a glass beaker and we have to add some concentrated sulfuric acid. Then you will get the sweet smelling substance of perfumes. So that is called as esterification reaction. Last but not least, that is cleaning action of soap in this lesson. So these are the very important questions in the 12th lesson. One more, naming of carbon compounds also important. Root words are very important. C1, C2, C3, C4, C10 up to C10. You have to remember the naming of remember that root words. It is easy to write the naming of carbon compounds also. IUPAC names. Understand? So suppose all single bonds are there. 5 carbon compound is there. That is a pentane. 4 carbon compound, butane. 3 carbon compound, propane. So if any double bonds are there, that is alkene group. Propene, butene, pentene, hexane. Or triple bond compounds are there. Propine, butane, pentane, hexane. So these are the examples for the IUPAC names of the carbon compounds. Okay, right? These are the very important concepts and questions to prepare in the board exam. Almost all previously you may have prepared, but once again revise this all the questions what we have discussed, then definitely it is easy to get the more than 36 marks out of 40 if you prepare well these questions. Along with the bit part also can be covered here only. If you understand the content of the lesson, then it is easy to write the bit parts. Okay, right? I wish you all the best to get the good score. Thank you.